What's up, guys? So right now we just have a quick demo of the new assembly editor. You can see that we have all of these assembly instructions now, as opposed to that messy array of commands from before of just all of the machine code opcodes. And then we also have a list of addressing modes right here, and this is not going to be the final form of this. These, I'm sure, would not be very user-friendly here, just because like we have stuff like a comma x and a comma y as our addressing modes, and when you look at this, if you were to write it out with a keyboard, normally you would put whatever your number was, and then you would put comma x after that, kind of like that. But that isn't the way that we have it right now, just because I haven't implemented that. However, in the meantime, I do want to show a demo of the assembler running correctly. And so we're just going to store something out to port B because that's a very simple operation to do. And you can then kind of compare that to an older video using the opcodes from before to see how that's going to work. So right here we have, I believe it's like 41, maybe it's 49, I don't remember exactly. We have some opcodes, they're all ranged into just like their category. We have like load, transfer, stack, rotate maybe, arithmetic, increment, logic, all of that sort of thing. But in the meantime, we're just going to grab out a load A opcode. And so what the difference here is, instead of turning around here and getting out A9 for load A like this, we get out a load A instruction. And you can see here that this A9 opcode already has load A and the addressing mode baked in. Whereas right now, load A does not have an addressing mode built in. And so we can actually select any of these addressing modes, and the assembler will figure out which, like, what actual machine code instruction to use. And so it'll perform all of this sort of stuff, putting it into that program in the background. And all we have to do is just write our thing in a little bit of a more abstracted language. And so we're going to grab out a hashtag # for our addressing mode so that we can just load in a number. And if we look here, we could type in everyone remembers 55. If we go into binary, you can see right there that is like half of that marquee effect from the one video before. Were we to create that, you see it would make us a 55 operand for our opcodes. However, what we're also able to do is create that in assembly here. And so if we create one of those, you see we actually, and it's not perfect, like you can see the text is kind of clipping off the edge, but you can see we actually have this %01010101. And that kind of shows that we have a binary number that we're attaching to our instruction, just like that. Whereas, say we were to go back and just take out a 55, well, now you see we have the little $sign. And so while these two are equal, maybe when we're writing our program, we want to use the binary one to make it a little bit more explicit what we're trying to do. Because remember, what we're trying to do is make this little on-off pattern show up on port B. And so instead of using 55, which might not make sense to someone just trying to read the code, we're actually able to put this binary right on there, and our assembler will handle converting that into like 55, the decimal that's necessary to put into there for us. And so we have one line of our program already, and we can actually take this line and attach it right up to our assembler right there, and it just kind of sticks on. And now we can work on our second line, which, remember, we're storing A. And so from before, this would probably be the 8D command, right? So 8D, store A absolute. And so you can see once again right here, we don't have the addressing mode yet, so we're actually able to pick out an addressing mode. And so we could attach this A to it. But technically, the assembler also would automatically detect the A. If we just wrote store A and then 6000 is going to be our address here, we could just throw that right on, and that would work as well. But we could also, write it out like this just to kind of show exactly what we're doing. And one other thing that you'll notice that our assembler takes care of is before with our 8D, we'd have to write out a 0, 0, and then a 6, 0, and have that all in little endian format all correct. Remember spending plenty of time with that. Well, now we don't have to. Now we just have 6,000, and we can attach that right onto our command, and then stick that right on below. And so if we hit assemble, you'll notice, actually, you can't see it on there just because of the way that I have this zoomed. Maybe if I move the scene a little bit, you can. You can see right at the bottom there where it says like 96. That was like one of the last thing printed out by our assembler. And so yes, it's in debug mode right now. But the assembler has written out on the debug console basically the assembled version of our program right here, starting with stuff like it starts off with 169, and it's to writing it out in decimal, but it starts off with 169. If we convert that to hex, you see that that's A9 hex, and A9 hex is load A immediate. So you can see how the assembler just kind of goes through this program and converts it into the less user-friendly machine code that we've been programming before. And then were we to go down a little bit farther, it would have generated the equivalent of 8D, and then also 0060 to handle basically our little endian format there. So we could then upload this program to our EEPROM. Now it's in that EEPROM of the computer, which pretty soon, since we already have like a monitor and everything here, pretty soon we'll end up having the computer right here, and you'll be able to plug in each of the parts of it. But for now, it just uploads it to the EEPROM. And then you can see right here, our processor's at 8,000, so that's good to start off with, right? We can then see right here, it hasn't read anything in or anything, but if we tick it once, we get the opcode A9. So obviously our assembler has correctly made this load A hashtag for load A immediate into the A9 opcode. And then if we tick it again, you see we get 55 right in there, and now our A register is populated with 55. And then store A, we'll tick it again. We get 8D, so you can see that that is the same 8D that we'd be expecting. The store A absolute, it's transformed that for us. And then tick it another time, we get our low of 0, 0, so that's the 0, 0 in 6,000. And then our high of 60, that's the other part of the 6,000. And what you'll notice is, look at that, port B is now lit up with the correct pattern. And so you can now kind of see one of the advantages, there are many, to using assembly here is you can see it's 0, 1, 0, 1, 0, 1, 0, 1. Yeah, exactly. So you can kind of see here how our binary that we wrote right here is a little bit more user friendly to kind of see how that final output is. And so we could even like we could get like a jump instruction and head back to 8,000, something like that. I'm not sure if it would actually like work right now or not. But one thing to keep in mind is when you're writing assembly, you probably wouldn't actually take your jump instruction and attach that to just like 6,000, right? Because yeah, like sure, we could write like another piece of this that like flips it to like 1010 and whatever and stores that out as well. And then throw on the jump below that, right? But jump to 6,000, or not 6,000, sorry. 8,000. Jump to 8,000 doesn't make a whole ton of sense right here. Because like if for someone reading the program, like what's 8,000? You know, they would have to know that our program counter starts at 8,000 because that's where our EEPROM starts, to like see the significance in that, right? And so therefore in the future we're actually going to be able to type stuff in on this thing. We could like write in like a label of like loop, and put that right here. And then if we labeled a certain spot in our program, like say we had a new like command over here, label, if we labeled that spot loop, right, then we could just have right down here, instead of jump to 6,000 or 8,000, we could have jump back to the loop. And so that way, you'd be able to actually kind of see like exactly where it's going. And that reminds you more and more of something like BASIC on some original computers, like the Commodore 64 BASIC. You start seeing stuff like go to being very similar to that. You could go to a line number, you could even go to a label, as we're kind of demonstrating here. So if we throw all that away, that's pretty much my quick demo of this brand new setup here for all of these instructions in assembly. Sooner or later, we'll get like a nice scrolling thing and not just like this little green like start thing, so that you're able to write like a nice long program. That's the point where we start being able to like make games or something like that, add a joystick, whatever. But probably the first thing that we'll end up doing is just rebuilding a few of our old programs from here, just to see how they work in assembly language, seeing how we can make them more readable, that sort of thing. And then moving on to something more complicated that you really wouldn't want to do manually. Maybe even something like printing out characters to our screen. Not sure exactly where we're going to go with this, but yeah, that is my update on the assembler for the 6502 simulator. And that was only a 12-minute video.